This is section 3.3 practice problems. So we'll go through those problems that you had in the book and work through those to make sure we know how to do them. Question 28, how many minutes are there in exactly 1 week? I always want you to set it up this way. Put down what you're trying to find. So I'm trying to find minutes. Put that equal to what you have. I have 1 week. Now set up your factor. Remember, we want to convert, and this is going to be multi-step to get here. So we're going to convert from weeks to days, days to hours, hours to minutes. So if we say 1 week is 7 days, 1 day, 24 hours, 1 hour, 60 minutes. And we want to set up a problem so it's like that. And at this point now we want to make sure we can cancel everything out. So weeks cancel, days cancel, hours cancel. I'm left with minutes. That's what I'm trying to find. So I'm now going to take 7 times 24 times 60. 7 times 24 times 60. And that's going to equal 10,080. 29. How many seconds are there in exactly a 40-hour work week? So once again, how many seconds equals 40 hours? So convert first to minutes. 1 hour, probably should be hour. 1 hour, 60 minutes. 1 minute, 60 seconds. Make sure that you can always cancel. Cancel those, cancel the minutes. I'm going to take 40 times 60 times 60, and I'm going to get 144,000 seconds. Up here it was minutes. Problem 30. An experiment requires that each student use an 8.5 centimeter length of magnesium ribbon. How many students can do the experiment if there is 570 centimeter length of magnesium ribbon? So what we're trying to find is students, and we have 570 centimeters of magnesium. What we do know is that it takes 8.5 centimeters per student. So that's kind of my ratio. 1 student, 8.5 centimeters. I set it up in such a way that this is going to cancel. Since centimeters is on top here, I'm going to put it on the bottom here, 8.5 centimeters. 1 student. 570 divided by 8.5, 67.058, whatever. And obviously you can't have parts of students, so we would have 67 students. So we want to know degrees Fahrenheit given 48 degrees Celsius. We know that 1 degree Celsius, 1.8 degree Fahrenheit. Set it up so that it cancels. That means Celsius needs to go on the bottom here. 1.8 needs to go on the top. 48 times 1.8, 86.4 degrees Fahrenheit is what we would get. Next one. All right, using tables from this chapter, convert the following 0.044 kilometers to meters. If we want to go kilometers to meters, so we're saying how many meters equals 0.044 kilometers. We know that there is in 1 kilometer there is 1,000 meters. So we're going to multiply by 1,000, move my decimal place 3 places to the right. I should get 44 meters. For the next one, how many grams equals 4.6 milligrams? 1 gram, 1,000 milligrams equals So we're going to multiply by 1,000, 4. 1, 2, 3, 4,600 milligrams. How many centigrams equal to 0.107 grams? Centa means 1/100th, so if I have 1 gram, I'm going to have 100 centigrams. Cancel that. Multiply by 100, I would get 10.7 centigrams. 33, convert 15 cubic centimeters to liters. How many liters? 15 cubic centimeters. We know, we said before, that there's 1,000 cubic centimeters in a liter. So 1,000 cubic centimeters, 1 liter. We're going to need to divide by 1,000, move my decimal, 1, 2, 3.015. I guess we're looking for liters, what we get here. Liters. The next one, let's go over here. Actually, let's just erase a couple of these so we got some room to work. How many milliseconds equals 6.7 seconds? 1 second, 1,000 milliseconds, multiplied by 1,000, 6, 7, 7, 1, 2, 3, yeah, 6,700 milliseconds. And last one, how many micrograms equals 94.5 grams? 1 gram is 1 million, or 10 to the 6th, micrograms. Funny looking U. Actually, Greek letter mu. So it's going to be a 9 and a 4. Now I move the decimal 6 places. 1, 2, 3, 4, 5, 6. That's what I'm going to get. 94,500,000 micrograms for that answer. Radius of a potassium atom. Got that. Okay. Radius of a potassium atom is 0.227 nanometers. Express this radius unit in centimeters. So, how many centimeters equals 0.227 nanometers? And I don't know exactly how to go from nanometers to meters. If you look up in your chart, you'll find that nanometer is a billionth of a meter. In other words, 10 to the 9th. So there's 10 to the 9th nanometers in 1 meter. And 1 meter, there's 100 centimeters. So always setting it up in such a way that they cancel. Now we're in 2 steps, and I'm left with centimeters. You know, this is 10 to the 2nd, so I could cancel that and end up with a 7. And I'm going to move my decimal place 7 places. So that's going to equal 1, 2, 3, 4, 5, 6, 7, 2, 2, 7. Or if we want to change it, whoops, not there. We want to change it to scientific notation. You know, moving our decimal place 2.27 times 10 to the negative 1, 2, 3, 4, 5, 6, 7, 8. 10 to the negative 8. Okay. Diameter of the Earth is 1.3 times 10 to the 6 kilometers. What is the diameter expressed in decimeters? Decimeters. 1.3 times 10 to the 6 kilometers. So, convert first. I'm going to go first to meters, then to decimeters. 1 kilometer, 1,000 meters, and then 1 meter, 10 decimeters. Kilometers cancel, meters cancel. That looks good. So I've got 1.3 times 10 to the 6th. This is a 10 to the 3rd. This is a 10 to the 1st. I can add all those up. So 1.3 times 10 to the 10th. I want to do that. Otherwise I get a really big number. Okay. This should be a 4. I can't read the thing very well. 1.3 times 10 to the 4th. Therefore, this makes this an 8. I did it all right, except I just copied it all wrong. All right, last page. Gold has a density of 19.3 grams per cubic centimeter. What is the density in kilograms per cubic meter? So kilograms per cubic meter. These are always a little bit tougher. Make sure you're aware about, going from cubic meters to cubic centimeters. That's the tricky thing. Cubics, when you go cubed, it's always a mess. Okay, 19.3 grams per cubic centimeter. I like to write it straight up and down. It's just easier to make everything cancel as I'm working through it. And do this as two problems. So, like I did before. Problem 1 is this. Problem 2 is that. So, let's do the first problem. To change from grams to kilograms, there are 1,000 grams in 1 kilogram. So that's the first part. To do the second part, to go from cubic centimeters to cubic meters, what you need to remember is let's do it this way. 1 meter equals 100 centimeters. Cube both, you get 1 cubic meter equals 1 million, or 10 to the 6th cubic centimeters. So that's my conversion. Cubic centimeters need to go on the top because they're on the bottom down there. 10 to the 6th cubic centimeters, 1 cubic meter. And then let's just cancel, make sure all my labels cancel. Centimeter, cubic centimeters cancel. I've got kilograms per cubic meter, so that's good. Kilograms, cubic meter. This is 10 to the 3rd, so I can cancel that with 3 there. So that's going to be 1,000. So 19, move it 3, 2, 3 kilograms per cubic. All right, number 37. There are 7.0 times 10 to the 6 red blood cells in 1 cubic millimeter of blood. How many red blood cells are there in 1 liter of blood? So what we really are trying to find is red blood cells per liter. And what we're given is that there is 7.0 times 10 to the 6 red blood cells per cubic millimeter. So we got to figure out how to get from cubic millimeter to liters. We don't have to change the red blood cells, so it's just that particular thing. So here's what we know. We know that a liter is 1,000 cubic centimeters. Well, we don't have cubic centimeters. We have cubic millimeters. So let's figure out how to go from cubic millimeters to cubic centimeters, and then I can go to cubic liters. So if I say 1 centimeter is 10 millimeters. Remember, just kind of keep it straight. In 1 meter, 100 centimeters, there's 1,000 millimeters. So I could use these numbers and do it. I could use what I've got up above. But since these numbers here are a little bit smaller, I'm going to use that. Now remember, because it's cubed, we do need to cube everything. Cube. All right, so let's start making our things here. Well, let's finish this one up first. 1 cubic centimeter equals 1,000 cubic millimeters. So I can use that for this conversion. 1,000 cubic millimeters, 1 cubic centimeter. That cancels. Now I have red blood cells per cubic meter or cubic centimeter. Not what I'm looking for, but I do know one more conversion, and I can get there. I could say 1,000 cubic centimeters, 1 liter. All right. So now I just going to multiply out all this, 10 to the 3rd, 10 to the 3rd. So a 10 to the 6th times a 10 to the 3rd times a 10 to the 3rd is a 10 to the 12th. So 7.0 times 10 to the 12th red blood cells per liter. Pretty tough problem. If you got that one right, you should give yourself a pat on the back, because that is certainly a challenging problem when it comes down to it. All right, I think that's it. Hopefully from this you've got an idea of how to do all of these problems.